morning, everyone. Thank you for tuning in. Thank you for tuning in, and thank you for joining us locally. I'm excited to tell you guys about a new shift in the technology world, coined web containers. So, from a junior's perspective, the full stack environment can be very tricky to navigate, especially if you view all the different technologies as play, from the front end to the back end to the different languages that you have, and all the layers that you interact with. And in comparison to what we have at varsity and what we had in our first year, and maybe when you just start coding, you have these built-in compilers like Visual Studio or VS Code. And I remember back in my second year, I walked into my very first Java class, and on the board, there's this random slide that says you need to download the JDK and set the environment path. I'm like, what on earth is this? Everybody is running around, everybody's trying to figure out what the environment path is. Needless to say, it was just a simple path into the bin, but at that stage, it was Greek. Fast forward to my third year, I had my very first web exposure in a third year subject where one of my lecturers kept mentioning this name Node. And in comparison to Java, where it's the Java runtime engine, which is quite easy to understand, it's the underlying engine. When I started reading about Node, these random names that run synonymous like MPM and Yarn and the V8 engine, and it is completely bonkers to try and figure out what all these names have to do with one another. And it literally got me to the point where I bought a Udemy course because I couldn't understand how these things fit together. And all the while, I still had to try and decide which front end and which mobile framework to use. I mean, that in itself is also quite a different topic to talk about, because there's so many biased opinions online about which front-end framework suits which different use case better. And once you actually start going through this environment, it's quite daunting, to say the least. Because once you start reviewing all the different layers at play, all the different integration layers, and all the different technologies that work together and talk to one another, it becomes quite a difficult situation to try and understand, especially as a third-year student. I mean, although we had networks as a subject and all these very complex theoretical subjects which take you through protocols and multiplexing and all these different layers, they really ever pose the question to you, what's the actual difference between an API and a web service? And which one to use where, or which technology is suited to which environment best? So fast forward, I graduated, and I quite delved deeply into these topics, and I quite delved deeply into the various different layers at play, and I really threw myself into it. And it really, after varsity, it felt like I knew a lot, and I conquered the world, and it was a surreal feeling at that stage. And I thought, I know enough to contribute to a team. I know enough to be dangerous. I know enough to handle some difficult situations, just to join my first team. To be greeted with, here's a link, here's a doc, we need this Friday. No help, no nothing. I literally felt like going from this massive teddy bear to like, he's pointing a gun at me, he needs this Friday, I have no clue. To be overwhelmed by it's not as easy as just running the install file, getting your local setup ready, and start coding. Because there's VPN issues, there's security issues, there's legacy code, there's outdated libraries, there's different jar files that I need to pull in that are not maintained on the registry anymore. It really boggled my mind to the point where I couldn't understand that isn't there some better way to do this? Is there not a better way to do onboardings? Is there not a better way to access your tech stack? And that following Monday, however, after my machine got set up, which took about a week and a half to 2 weeks, by the way, I got into my very first stand-up where my machine is ready, the repos are ready, everything seems to be functioning the way I want it to function. And I'm greeted by my Scrum Master and my actual project manager at that stage. Have I had a look at the backlog of tickets that are available? And I don't know if any of you have tried explaining to non-technical people that setting up a laptop with your local environment, it's not that easy. Sometimes a lot more difficult than it should be, in my own opinion. But that initial section was delivered from UAT to prod, and we branched off. And why I actually initially joined the team was for the new section. And at that stage, we created our new section. And as developers are, we reviewed the stack that we are working in. We reviewed the versions we were looking at. And Also, we found that some of our material design stuff were outdated. Some of the versions we were using were not up to par with what we want. And we as developers, obviously, we like toys, we like new tech, just like games. We like getting new stuff and new DLCs and new skins and crafting and honing our craft as much as we can, because it's what makes our industry amazing. So me and my team lead decided we're going to go on a mission and upgrade Angular version 8 to Angular version 10. And compared to your local environment with a simple NPM install, at times it was like reading hieroglyphics, going from just version 8 to version 9, never mind jumping to version 10. And it really left me at times feeling like, I don't know what's going on, because it's dependencies upon codependencies. And once you fix one, there's 4 more that get added. But you live and you learn as a junior dev, and you explore, and you can't approach problems with the same mindset you did when you created them. But just to add a little bit more insult to injury, just as we got going, there was a little bit of issues in UAT, which my team lead had asked me to go back and check. And I switched to that branch, and I was greeted with a nice big red sea of errors, because that branch was still on Angular version 8. Needless to say, after scouring around for 2 hours, because I don't want to ask someone a stupid question like, how do you navigate versions between branches? I figured out, okay, well, you just clone the project twice and you just navigate that way. It's the easiest. So as amazing as the full stack environment can be, and as beautiful as it can be daunting, and it can be very frustrating at times, and it really can leave you thinking like, am I missing the point? Because you are doing exactly what the command line says, for example, installing your codependency, then just 4 more pops up, or a dev dependency and just more pops up. I mean, in comparison to what's around us, the environments that we work on locally, compared to what we have in the cloud as elegant continuous building solutions and integration solutions and testing solutions, it's pretty mundane what we do when we try and onboard someone and get them integrated into a project. And especially in comparison to what we have in the newest tech trends going around with AIs writing code and elegant streaming solutions and IoT solutions. It really is frustrating to try and understand why these elegant solutions exist, but yet we still struggle with these small little tasks to get our code going. All these various layers, although all the layers of the full stack system can provide a beautiful ecosystem like the Earth, if one of them does fall over, it truly affects the whole outer system or the inner system of what works and integrates with it around it. So I myself am a very curious character. So I like to explore the tech I work in, and I like to explore in and around what I do, and try and understand not only why I'm doing it, but how it works under the hood. And I subscribe to quite a bit of like weekly podcasts, and I spend my time not watching TV, but rather reading and listening to what's new. And for the guys that do listen to podcasts, I can highly recommend for the web environment, JavaScript, Java, JS Party. For the guys from other ecosystems, software engineering, the changelog and shop talk, it's pretty good. But it was one night, I was sitting, it was late, I was working on a feature, and I was listening to one of the Google I.O. keynotes, and their weekly newsletter came out, and I started reading the newsletter. And apparently there was a company called Stackblitz that stole the show at the Google I.O. keynote. Now, my first initial thought is, how do you steal the show from Google at their own keynote? How's this possible? I mean, they literally own the web. And throughout reading this article, I came across a term called web containers, which my initial thought was it's a typo because we already have containers. Turns out it wasn't. I also came across WebAssembly and the WebAssembly system interface, and a very funny project called Project Fugu, which is a pufferfish. Apparently, the comparison is when you cook it correctly, it's beautiful, but when you cook it wrong, it's deadly. So it seems like somebody shared my frustrations, and they decided to build a company out of it. And throughout reading, I also discovered why our local development environments were so susceptible to security breaches. And also, throughout reading and discovering this, I also came across a very new latest survey, which was released at the end of 2020, where top security companies and top Fortune 100 companies stated that their local development environments should be more secure. And throughout reading even further, throughout the ecosystem, which I have grown to love so dearly, I found the famous MPM Worm, which was discovered by Sam Saccone. And for those that don't know, it's actually still on their bug list till today. So This worm self-propagates due to 3 reasons. So open source package maintainers on the NPM registry, which have author accounts, can publish minor versions on the NPM registry. Or when a package version is within a minor, post-install scripts run with full admin access by default on your machine. And I don't know how many web developers are in the audience, but you don't have time to check out every single package which gets installed or gets minor updates. And also, you don't get notified when a minor version does indeed get an update. So it runs its post-install script by default and republishes to the registry. And all this due to just small little underlying problems in the registry, like, for example, the fact that there is no peer or code review process when something gets posted to the registry. And this was indeed confirmed by the actual survey itself, that the main risks highlighted in the survey were lack of security over CI/CD pipelines might create backdoor to organization, networks, and infrastructure, as deemed by the open source packages. They call them supply chain breaches. Access to CI/CD tools, like, for example, Jenkins, which is indeed open source. You can analyze how Jenkins works and inject different malicious software into Jenkins pipelines and just gain full access to it, and user misconfigurations, which might result in code and secret leaks. Very notable cases from 2020 and 2021 of these examples are SolarWinds, which the normal routine bug fix and performance update released a Trojan into the SolarWinds network. And this Trojan went undetected and propagated as far as Microsoft and even Intel. So if they are susceptible, how much more are any development company or any other company that uses software? More recent cases, for example, are Audi and Volkswagen, which had 90,000 of their records, private records, leaked through a third-party database package in one of the open source CI/CD pipelines. Another one, for example, is Xelion, which is a third-party file transfer service, which was attacked in an unreported, unfortunately, security flaw, but on their logic gate, which also in the article stated that it was an open source package. And it leaked sensitive medical info from Stanford and various other insurance institutions. So what does WebAssembly system interface, and Project Fugu, and everything I mentioned have to do with this? Let's start with Project Fugu, because I think it's the base for everything. So I don't know if anybody remembers the Chrome apps that you could install in your Chrome browser at a stage. It was fundamentally deprecated in 2017, and end-of-life support will be in 2022. But the APIs that were used by these apps were stripped out and utilized as a base for Project Fugu. And it is an initiative led by Google and Intel and Microsoft and various other companies, larger companies, trying to create an indistinguishable-based experience on the browser compared to your desktop-grade experiences. Notable APIs from these APIs, for example, which will come into play later, as you guys will understand, are the Service Worker API, which basically acts as a proxy between your actual application and your network, and can asynchronously in the background perform certain actions based on what is available or what is not available, or indeed how you want to utilize it. Non-blocking. For example, it allows progressive web apps to dock on your system, and then it also allows it to function without internet connection. Another notable one to remember would be the File System API, and one of Google's I/O keynotes stated that the File System Access API is one of the most exciting browser-based APIs to have launched in recent months, purely due to the fact that it does not have access to your direct local storage, but it can target your local storage to a virtual drive system that gets mounted inside of the browser sandbox. So in essence, although the data gets stored on the local hard drive, it does not have access to the local hard drive, but the underlying browser engine processes do, and not the actual app itself. So allowing these apps then to function as desktop-grade apps, although they don't have actually access to your local underlying hardware directly. For those that are curious and maybe want to check it out, the Fugu initiative does have an API tracker, and you can go and check out which operating system support there is, also if it has a progressive web app support, and also when the release timelines are, and also when the next release would be. There is also a beta program for you to sign up. So then, what is WebAssembly? So to understand WebAssembly and where WebAssembly was targeted at, you first need to just gain a very high-level understanding of how the web works. So JavaScript runs on a virtual-esque machine. It's not truly a virtual machine, but in comparison, it is very similar. And it interacts with the document object model through certain handlers and mutates what is on the screen through these APIs. So as technology progressed, this virtual-esque machine became sluggish. And this is where WebAssembly came to fruition, and the idea for WebAssembly came to fruition, because the performance of the browser-based environment was becoming sluggish. And WebAssembly is basically just a low-level assembly language with a compact binary, and it provides near real-time performance. And I'll discuss the security around it in a moment. But what WebAssembly allows, what makes it brilliant, is the fact that you can take your developers from any walk of life and use the WebAssembly compilation target to bring that down into a WebAssembly module and slot that right next to the JavaScript inside of the browser and utilize it. It is also very suited to the web environment, as I explained earlier, that the JavaScript interacts with the document object model through API methods. It's called this capability-based security model. And WebAssembly basically works on the exact same model, utilizing the best of what JavaScript offers and the best of what WebAssembly offers, but allowing them to work in cohesiveness inside of your browser. So the WebAssembly system interface is an initiative to take what WebAssembly does so well and extend it beyond the web, allowing you to use your WebAssembly modules to run them not only in the browser, but to run them on edge or on local bare hardware, which you guys will understand at a later stage during the talk. To bring this into perspective, everybody knows Docker, but the CEO of Docker stated on record on Twitter that if WASM and WASI existed in 2008, they would not have needed to create Docker. That's how important WebAssembly on the server is for the future of computing. And one of the principal engineers, which is part of Azure Core, Matt Butcher, stated that WebAssembly can do many of the same tasks that a container does, but it has a different operational profile. It can be run with far fewer privileges. It is smaller, and it is cross-architecture and cross-OS. So before we dive into Stackblitz, let's first review what is available for us as developers in our ecosystem and what online IDEs we do indeed have. And most of these IDEs work basically fundamentally on the exact same principle. They connect to a remote instance, and all of them are in essence hidden behind very steep credit card paywalls, which in most cases are ridiculous. You cannot work with another colleague, because if you do indeed share the link, they will indeed hit a credit card paywall. And in comparison to our local hardware, most of the VMs you do connect to are not even a quarter of the processing speed you do have. And if that VM indeed does break or fall over, when you hit the refresh button, it just connects you to the same broken VM. So what does that even, how would that even help us move forward? Compare that to your local development environment, where you just basically pay for your internet and your electricity. It's a very hard sell. So when I just joined BBD, I joined a team with very strict guidelines for UI, and I remember getting a link to Figma, and I was completely blown away with the ecosystem which was presented in front of me, that we could work on one UI in the browser, that if you docked the browser and eliminated the border, it truly functioned like a desktop-grade experience. That mouse pointers were moving around with faces next to it. We could discuss stuff in real time, move stuff together. There's a full community where you can share stuff. I can drop you a link. It is free to access the project that we work on. It is mind-blowing. And fundamentally, we as developers, we don't have these types of experiences. We are barred to our local development environments. We are barred to them because we need the underlying resources to do most of the stuff we do. And we need the admin access in most cases. So Stackblitz. So Stackblitz attempted the impossible. I mean, nobody would have even dreamed up what I'm about to explain. But Stackblitz used WebAssembly to create a WebAssembly-based operating system which mounts inside of your browser. It completely builds from the ground up inside of your browser. And inside of this, they created a VS Code clone IDE, which inside of that mounts a web container. So web containers are very much the same as what the Docker Open Initiative is targeting, to bring a form of standardization to this WebAssembly operating system in the browser, and to allow everybody from all walks of life, all the developers, even at a later stage at Stackblitz V2, they're targeting memory managed models, but to bring your compilers and bring everything to the WebAssembly-based operating system and bundle down your compilers and hook into the web container ecosystem and utilize this whole environment, allowing you to not harness only the ease of use, but all the pros, as mentioned before, all the security, all the efficiency, and all the speed. So as that seems to evolve, so too will the WebAssembly system interface evolve. So not only will you be able to utilize it across your different browsers, but also across different architectures in your own language using your own skill set. To put some cherry on the cake, you can even mount your WebAssembly-based modules in the browser and inspect them using the Chrome DevTools. And if there are any bugs or issues, you can put breakpoints in them, and you can then debug them that way. You can use the JEB to decompile them down into human-readable pseudocode. So if a different part of your project needs that, they can do that as well. Or you can use WASM to decompile most of the code into generic functions, which most developers should be able to understand and read. So through the use of the Service Worker API and through the use of the File System API, they built not only a browser-based IDE, but it is also a progressive web app. And this progressive web app has absolutely zero setup, uses your local hardware through the process of the browser, and has local key binding support, much like your own VS Code instances or whichever IDEs you use. Here's an example of someone taking a desktop app, dropping it in the browser, and boom, the server loads. In most cases, this is much faster than your local development environment and outperforms your local development environment due to the fact that I will explain a little bit later. But then fundamentally, most of you are probably wondering, okay, so it's a little ecosystem in the browser. What makes it better? And what makes it faster, as I just asked the question. But Stackblitz, compared to your local environment, on your local environment, when you open your VS Code instance, VS Code is built on Electron. And every single package you install on your VS Code instance has its own thread or has its own process starting on your server. Your CMD, which is running your development server, has its own thread running its own V8 copy. Then also too does your browser. So you have multiple instances of the V8 copy running on your local machine just to develop one app. So what Stackblitz did was they stripped Node completely out of the V8 engine and ran it through their operating system directly against the V8 copy of the browser, thus utilizing the single thread that is used, the single process that is used by the browser. But through this, they used isolates and context. More so context than isolates, but an isolate is the mechanism for the V8 engine to basically just isolate and allocate memory for code that is running, and code within an isolate cannot share with another isolate. But context is what they utilized heavily. The context is very similar to a isolate, but it has multiple chunks of code running it and may share that context. Through this, a single V8 instance can run all of what you would usually use on your local development environment through one copy of the V8 engine, hence alleviating all the inefficient process overhead that you currently saw. And due to the fact that they created the operating system and they own the operational layer of this operating system, they utilized some mind-bogglingly critical path execution by analyzing the current build cycle for what is needed on the screen and only installing the NPM packages that is needed for what is currently being displayed. Less and not more. And also because it runs within the browser, they are backed behind the optimization of the Google Chromium team. And your NPM installs and even your NPM refresh, when you refresh the browser and all the packages reinstall when the browser reloads the operating system, is in most cases almost twice as fast as what you could have on your local machine due to the fact that the Chromium team has provided so much optimization through the Chrome engine. So here's an example where you could basically just, for those that are interested, split it up, and it looks exactly like your local development environment where you can utilize your browser, you have autocomplete, you have your local key bindings, you can just drop it out, it's two separate windows, and it is as easy as that. So as I stated, when you refresh it, it is completely built from the ground up. So no longer are you hindered by the fact that if something does indeed break, that how are you going to fix it? When you hit the refresh button, the WebAssembly operating system and the web container and the full environment that you work in and all the NPM install files rebuild from the ground up, and it is near instant due to the fact that WebAssembly is so fast. Now, I know there are people in the audience that are very attached to their operating systems or to their browsers. But what makes this beautiful and what makes this so amazing is the fact that Chromium itself obviously is used in Chrome itself. Firefox uses a branch or a forked version of the Chrome engine called SpiderMonkey, and Safari uses Core.js, which is just another version of the actual Chromium engine. And obviously, Microsoft's Project Chakra failed, so they ended up using Chrome instead. I mean, it's Microsoft. So by now, before I forget, and in recent news, Apple announced that they are bringing WebAssembly threads to Safari. So meaning those new shiny Apple Silicon chips will also be able to run the WebAssembly operating system. So those new iPads can be utilized for development, and they have shown their guns in the horsepower department. By now, most of you are probably wondering, okay, so a lot of efficiency, a lot of cool stuff. What about the security? Because that's fundamentally what Stackblitz is. It's actually a security company through code. So usually you would connect to GitHub with an SSH key in most cases, but Stackblitz utilized OAuth and integration with SAML single sign-on. So you can restrict development to actually just a single server. You can only allocate, or you can open up your full barrage of your repos to a developer, or you can restrict it to a single repository. And in any case, then if a NPM package does indeed install that it's malicious on the browser, there's nothing to take. There's no SSH keys to take. And if you hit the refresh button, in essence, it will be rebooted from the ground up, and then nothing can indeed happen. What's even more amazing, those nasty NPM install scripts. So I'll explain a little bit more around the monetization and the premium model for Turbo, but Stackblitz created a NPM client called Turbo, which does not run NPM in post-install scripts by default. It does not update unless you initiate an update, and it can be utilized with a private registry. So if indeed you need to isolate your registries to private packages, it is indeed possible. And due to the fact that this whole ecosystem is inside of the browser security sandbox, it does not have access to your underlying hardware. It is completely isolated within the browser, and I'm willing to bet nobody's going to break the browser security very, very easily nowadays. So Google is pouring heavily into their resources into trying to make Chrome the go-to standard for what browsers are supposed to be, and trying to create indistinguishable web-based experiences through this. And also, as illustrated on the board, due to the fact that it is isolated within the sandbox, the file system API does not have access to your local hardware. So this is pretty much as secure as you're going to get. And what this allows is, due to the fact that Stackblitz is hinging on the browser, it means that you are always working on an evergreen environment. Due to the fact that the Chromium code base is being barraged by 15 to 20,000 CPUs daily, looking for security flaws. And as updates get released, and as security version updates get released, so too will the actual development environment that you are working in. The underlying Chrome engine is always utilizing the latest of security releases, and also to the security parts, and also the APIs that's running inside of the browser. So securing your development environment from being outdated. Now, by now, I'm also betting most of you are wondering, what about my extensions? So Stackblitz V2, which is going to launch at the end of the year, is aiming at not only providing extensions for the IDE, but you will be able to develop inside of the IDE extensions and publish to the extension store to utilize within the IDE. And this is pretty bonkers if you review. Just 5 years back, we are developing from local to the web, but what they are in essence doing is allowing us to develop for the local from the web, allowing us to target multiple instances, hence developing for the web through the web. So as far as free and premium monetization models go, Stackblitz, everything is free and everything is free to use. But there are some premium offerings that indeed are available. So firstly, because Stackblitz is WebAssembly-based and can run through the WebAssembly system interface, what this allows is for you to utilize the IDE on your local servers, behind your firewalls, within your VPN, or air-gapped, which is a disjointed network behind your own VPN, with use of custom MPM registries, allowing your full development environment not only to make use of all the security and efficiency from the browser itself, but you can actually build it into your own little security VPN of the company as well, allowing your developers to directly connect via secure services as well. Everything else is free. Everything else allows you to log in, prototype, debug, log in, connect to GitHub, push the stuff, and even they even have a dedicated just push to the repo button directly in the corner, which you don't even need to reach for the terminal to push your code to the repos. It is truly mind-boggling, and I indeed encourage everybody to go and have a look at it. So to close, I am willing to bet that Google is not going to stop pushing their browser to the limits. They are funneling resources into creating experiences on the web, trying to make the line between what you do on your local PC and on the browsers indistinguishable. They are probably trying to completely eliminate what we do on our local development environments, trying to push this as far as possible. And I'm willing to bet that most normal workflows, which we currently do have, are going to be left redundant. But as seen on the right on the steps, ideas are spawned out of ideas. And I truly believe that if this ecosystem takes fruition, we are going to see CI/CD pipelines which can develop directly, which can kick off directly from the browser through WebAssembly-based systems, and also directly connect into servers to push your code directly out as well. And what this will then allow is developers from all walks of life, from every single technology stack, from all experience types, to not only utilize their skills within their own space, but allow them to target the WebAssembly-based compilation target and bring their skills and their skill sets to a broad ecosystem. Because as I stated earlier, not only will it be able to run within the IDE in the browser, but also on hardware, on edge cases, and on bare metal, allowing you to hone your skill set, what you have and do, to a wider, broader use case. And as WebAssembly and the WebAssembly system interface develops, we don't know where it's going to go because it's still in its infancy. For now, there's what I just told you, but we don't know what is next. We don't know where it's going. So I leave you with my final thought. If you embrace possibility thinking, your dreams will go from molehill to mountain size. And because you believe in possibilities, you put yourself in a position to achieve them. Thank you.